All right, so here's our next example. And again, notice that the format of the function has changed. Whereas before we had the x's and y's on the same side of the equal sign, now it's just y equals negative 1 half x minus 8. I know that's not a y, you guys, but remember function notation f of x, that indicates that's the y value right there, all right? So the first thing I do on this, now I'm looking for the y-intercept. I'm not starting with the x-intercept. And again, the reason why that is because in this y-intercept, the x value is 0, then I find a corresponding y value. That's because all the operations are with the x side of things. If they were with the y side of things, I'd choose a y value first. But this side, see how it's negative 1 half times x, and then we'll subtract 8? That will give me a y directly. I can pretty much put this expression in the calculator and solve, okay? So right here, we can see with the y-intercept that it will replace the x value with 0, which I will do. So let's make that x is 0. So now we end up with negative 1 half times 0 minus 8. And again, I'll just show this as y equals negative 1 half times 0 minus 8. But remember, anything times 0 is just 0. So again, that's the important part here. And what we get then is just y equals, remember, it's not just 8, it's negative 8 because of the minus sign right there. You have to be careful of that. So the corresponding y value when x is 0 is negative 8. So 0, negative 8 would be the y-intercept. That's important with this format, which we'll cover more in a later lesson. But 0, negative 8, I'll go and put that on the graph right now. It's about right there, okay? Now, I just need any other ordered pair. Any other ordered pair will do. And so I see I'm multiplying by a fraction here. I wouldn't want to choose a 1 in this case because it's going to keep a fraction in the answer. I don't want that. What I'd like to do is get rid of that fraction. So see how the denominator is a 2? I just need to multiply this by any multiple of 2, and that will essentially get rid of that denominator. So you could say replace your x with a 2, a 4, a 6, or an 8, or so forth. I mean, we want it to fit on the graph, but anything will do. I'm going to just start with the lowest one, which is 2. So you can see here in the equation, I'm going to now replace the x with 2. This will require a little bit more work than the y-intercept was. But by replacing that with 2, negative 1 half times 2, yeah, see I get negative 1 right there. And then I will subtract 8. Just put that in the calculator, and that will tell you the corresponding y value here is negative 9. So 2 and negative 9, that'll fit on the graph. If it didn't, then I would have to go back and see what I need to do. But 2, negative 9, where is that? 2, negative 9, about right there. Now, some of you may be using slope at this point. We haven't gone over slope, so that's why I'm using this format. And yeah, some of you may even say, well, look, Sal, can I just put this into a table and then say 0, negative 8, and then 2, negative 9? Yeah, it's the same thing. It's just keeping track of their ordered pairs differently. But what we have right there is good enough to make the graph. And so however you do it, again, if you're doing it by hand, that should be enough. But, you know, I'm using electronics here, so it shouldn't be too bad to do something like this, okay?